So welcome to all of you, and today we are going to discuss lecture 4. Okay, and in this we will discuss the application of Gilman reagents. Okay, when you will add another reagent. Okay, so in this you can see lithium aluminum hydride is added. Okay, so such type of problem you can solve by assigning its cyclohexane, means it is the chair-like structure. So first the chair-like structure, and after that the function of lithium aluminum hydride is conversion of ketone to alcohol. Okay, so it is converted to alcohol. Okay? It is converted to alcohol. But question is that which it is hydride will attack an axial or equatorial. Okay, when CS3 present at axial position, okay, then it comes at equatorial. Okay. But in this, it present at equatorial, then it will attack from axial. Okay, so axial hydride will attack. Okay, after that, pyridine is added. Okay, so pyridine acetate is added. Okay, so function of pyridine, it forms pyridinium ion, you can say, and it is act as a nucleophilic, means as it's abstract by this pyridinium. Okay, and forming the pyridinium H. Okay, so after that what form it formed the anion. Okay, which attack on the acetate. Okay, this is the CS3COAC. So it will attack on the C. Leaving group is OAC, so it will released out and forming the OAC, means OCOCS3 acetate. So OCS3 will form here. Okay, after that flipping occurs. Okay, so you can see here flipping is occur, and the flipping when occurs, what happen here, this structure will look like that. Okay, means it will back, you can like that. Okay, so it will convert, means it is equatorial, so it becomes at axial. Okay, and it is equatorial, it become axial, means all the equatorial converted to axial and axial converted to equatorial. Okay, so it looks like that. Okay, after that this CST will be added on this, means nucleophilic center. So this is C, and this charge density will transfer here, and OAC will be released out. Okay, so it is axial, and this one is equatorial, means it attack will be the equatorial. Okay, so why axial will not express, because OAC is bulky group and preferred side is equatorial. Okay, so AE product will be formed reference to this one, means 1,3 bond will be the cis. AE means cis form, but 1, 2, 3 1, 3 position is when 1, 3 at 1, 3 side A and E bond present, then it is trans. Okay, if 1, 2 E and A present, then it will be cis. Okay, so it is the trans product, so your product will be the trans, so it is the product. So, okay, so like that you can solve. Okay, similarly you can see here, this is the aliphatic moiety which will attack on the nucleophilic center. Okay, and double bond, this convert, this charge density is shifted here. Okay, and it ring opening occurs. Okay, so product will be this one. Okay, acid will be formed here. Similarly, this is the multi bond, you can say triple bond is present, and this converted on this position, and it is acts leaving group. Okay, so product will be formed here, this one. Okay, means cumulative, you can say cumulative double bond formed here. Our CS3 is the another motif is extra added here, and it is released by the Gilman reagents. Okay, so this is the cumulative double bonds. Okay, the two types of double bond. If alternate, then it is conjugated, or okay, and or annually, you can say. But when double bond takes place alternate, then it is called cumulative. Okay, cumulative double bonds. So product is this one. Another is nucleophilic addition reactions. So Michael addition mainly gives 1,4 substituted 1,4 addition at alpha beta unsaturated ketone. So 1, 2, 3, 4 means you will be count one position 1, 2, 3, 4. So directly without stereochemistry you can add here. Okay, but when stereochemistry is given here, then what will you do? First you will attack from this 1, 2, 3, 4 means you will attack, and there is no substitution, then product will be fish, it will means addition takes place like that, it will on wedge. Okay, After that, what happened here? This double bond will be migrated here, so negative charge will be generated on this carbon. Okay, and this negative charge attack on the R minus means addition takes place at the SN2 type. Okay, so it will attack on the back side. Okay, so this is your product. Okay, you can see here. Okay, next this cancel addition takes place on the base. Okay, you will remind, you will हमेशा ध्यान रखिए, you can understand that this bond will be when Gilman reagent aliphatic substitution Gilman reagent adding here. So one for addition on the wedge. Okay, next will be the present means on the back side. Yes, present. So it will your product. Okay. Sin elimination. What is the sin elimination? You can see this hydrogen means forming the double bond here, and this is act as a living here. So olefinic double bond from here. Okay, and it acts as a living group. Okay, so it is a sin elimination. I have mentioned that you should be know about the sin elimination. If any in this type of NO is present, then sin elimination takes place. Okay. So another example is this one. You can see a CS3. Okay, so it will attack, first of all, it will attack on this carbon, and this charge density will transfer in this position. Okay, but okay, so after that, what takes place? It when it migrated here, this double bond also O minus will be formed. This charge density will transfer on the oxygen. Okay, so that's why you can see here O minus will be formed. So here hydronium is added. So it acts as a acidic, means it provides the H plus. So OH will be formed here. Okay, after that, this will migrated here, and this double bond shifted, means charge density will be shifted on this one. Okay, so this will form here. Okay, okay, so similarly you can see. So it is, so if you add Ri here, okay, so what happen here, this will transfer here, and after that this charge density will attack on the R minus, and iodine will be released out. Okay, so it from the this one, this product will be this one. Okay, you will consider always that this moiety will on the wedge, and remaining groups when comes here, it will addition takes place on the dash. This bond will comes towards you. Okay, so you will also draw this structure, means one is axial and one is equatorial. Okay, so this is the trans. So trans is the one, this is the trans, this 1 2 3 means 1 and 2. Okay, this is axial, this is axial, so this is the trans. Okay, so your bond is always this bond is trans, so this is A, means trans product is formed here. Okay, means trans product not formed. This is the representation of this molecule. Okay, so after that, what comes here? You can see here this one. Okay, so this is the structure of this one. Okay, but here you can see here this charge density when migrated here, and this comes here double bond, you will also draw like that structure. Okay, so consider this one structure. Okay, but your product will be this one, because in Csir-Net this answer is if not given, then this one is given here. Okay, so this, if this product will be given, then your answer will be this one. Okay, so similarly this you can see here, I have also explained here this one. It is very important questions and have been asked in CSI on it. Okay, so you can see here, this is the phenyl selenium. Okay, so when attacks, peroxide will attack, then what happen here, this forms selenium oxide. So this charge density further capture the hydrogen from this means this is the waste, and then this hydrogen will be the on dash waste. This is the waste, this is the dash side. So this hydrogen captured by this electrophilic nucleophilic moiety, and this hydrogen will shift here. Okay, so double bond will be formed, and this moiety will act as a living group here. Okay, so it is released out. Okay, so it is the some best example, and this example have been asked in the Csir-Net and GATE exams, and some questions have also been asked in the IIT Advanced. So after this scene elimination, or you can say beta elimination, beta hydride elimination, we will discuss here. So in this, you can see here, this bond, this CS3 will attack this position, it will attack on this one. Okay, so your products, it is already present. So this is on wedge. Okay, so new groups which comes here will be present on the dash side. Okay, so it is the trans products. Okay. Similarly, you can see this one, and this CS3 will attach in the wedge. Okay, so after that, this charge density will present here because this charge shifted on the oxygen atom. Okay, again this will backward, this will shifted here, and this charge density will be present on this carbon. Okay, so this nucleophilic center will attack on the this one, means it captured. Okay, and when captured, this from the it will this remaining new group will come on the dash side. Okay, so adrenaline junction cis stereochemistry will occur. Okay. Similarly, you can see it is very important question, and this in this type of questions you should remember that when this bicyclic, you can say this is the bicyclic compound, when given as a substrate, the remaining group will attach on the wedge. If this wedge, this remaining group will come on the wedge. Similarly, you can see here, so when methyl, this Gilman reagent attacks, first of all it will attach in this. Okay, nucleophilic, and this nucleophilic side means this, sorry, this much more electron density is present here, double bond. So electron density shifted in this. Okay, so like that, when backward, then this double bond will attack on the this carbon, and bromine act as a leading group. Okay, and your product will be this one. Okay, so similarly, you can see these reactions, and in this Gilman reagent means methyl will attack from this one, and it comes on the wedge side. Okay, and after that, likewise, like you can say like this charge density further backward, move in the backward direction, and these electron density will attack on the bromine, this carbon center where bromine is attached. Okay, and product will be formed on this, both groups will be on the wedge. Okay, so you will consider this one. Similarly you can see these products. Okay, so this is the substrate, this is your product. Okay, so what happened here, methyl will attack, where it will attack, it will attack from this carbon, because 1,4 addition takes place, 1,4 Michael addition takes place. Okay, so this one this product will be formed. Okay, so how it will you can see here, first of all this methyl will attack on this you can say nucleophilic center. Okay, and this charge density will transfer here, and these bond will migrate, and mean charge density will be shifted on the oxygen, O minus will be formed. Further this O minus will backward and backward. Okay, so this double bond further capture this H plus, which is given by the hydronium ion during the workup. Okay, so your product will be this one. Okay, similarly you can see this one directly 1,4 addition takes place, and methyl group attached from this carbon. Okay, you will always you will count from 1 this oxygen to this one, and 1 2 3 4. Okay, similarly I have also explained that this methyl will attack on this carbon, and when you will do the stereochemistry, then what happen here, you always on the waste side you will add. Okay, so methyl will present on the waste side, and after that this step takes place. Okay, which I have explained here, so there is no meaning of further explanation. Okay, so this charge density further attack fish carbon, this one. Okay, actually, okay, this, or you can say it will attack on the this center called this CBR. Okay, so this is the p orbital actually, and this bromine will be released out, and this moiety will be present on the dash side. Okay, So you can see here methyl. Further you can see this type of example. So methyl will attack from this position and it will adding as this side. Okay, so after this when you will add phenyl selenium, this charge migrated further like this, and these double bond will attack here. Bromine will be released out. After that, it form selenium oxide. Okay, and after this oxide will obstruct the hydrogen which is present on the that side. Okay, and forming the double this one. Okay, forming the double bond. Okay, so when it captures this bond shifted here. Okay, and this will be released out. So this your product will be from this. Okay, similarly you can see here this is the 1,4 addition, and when phenyl will attack here, so what happened here, this charge density will shifted here, this bond break down and forming the O minus where electron density is much more. So after that this electron density will come back and this double bond attack on the selenium. Okay, and bromine will be released out. After that this selenium you will after this H2O2 is added in the reaction medium. Okay, so when you will add H2O2, oxide will be captured by the selenium, and these O minus abstract the hydrogen. Okay, and forming this one.